ambiguous, the law of signs ambiguous case. And I'm going to show you get my graphic organizer. Here it is. And if you remember, there's out of these 6, there's 4 of them that show triangle congruence. Which 4 show triangle congruence from geometry? What do you remember? Side, angle, side. Angle, side, angle. No. Side, side, side. Angle, angle, side. Angle, angle, angle can only show similarity, not congruence between triangles. And side, side angle would like to say that there's congruence. However, we have problems that exist because backwards is spelled donkey. That's bad. Okay, so we're going to work through that today and see what that really means. And as you follow this flow chart, this is going to be important for you. You either need to learn how to use a flow chart or you need to have this ingrained in your brain. So you decide what you want to do. But the idea is this. The first step is we need to look at the side opposite the angle. If it's longer than the other given side, there's one solution. We'll use the law of sines. If the side opposite the angle is shorter, then there's either no solution or there are 2 solutions. These are the 3 scenarios that we run together today for side-side angle. Are you ready? Let's do it. Suppose we have this kind of triangle. Call it a 30-degree angle. And we'll say that this has a length of 20. And then I'm going to draw another side with a length of, we'll say, 14. Does everybody agree that that's a possible triangle? That that's a reasonable triangle? There's no conflicts with what I have written there. Okay? Everybody agree that that's a side-side angle triangle? Look at this angle right here. Is it acute or is it obtuse? I will create another triangle that has the exact same properties of the side-side angle. It'll have an angle of 30 and a side of 20 and a side of 14. Only it will be a different triangle. Watch how I do it. Agreed? That also has a side length of 14 right here. It has a side of 20 and it has an angle of 30. What do you notice about this angle there? You wonder why that is. Why does it work out that we can swing it on the pendulum like so and get these 2 options? That's why the triangle congruence theorem does not work. That's why side-side angle is not one of your options when you're talking about triangle congruence. Well, let's look at the law of sines and what it tells us. If you got sine of theta is equal to 0.7865, you tell me in which quadrants is sine positive. 1 and 2. So if sine is in the first quadrant, is it acute or obtuse? Acute. Could sine be equal to 0.7865? And that would be in the first quadrant with acute. Could sine also be equal to 0.7865 in the second quadrant? And then it would be obtuse. You don't know which one it is. So therefore, you have 2 triangle solutions. That's the visual you have to keep in mind as we do an example later on today. Discovering when it has that second solution is tricky. Let's look at the option where there's absolutely no solution. Okay? I'm going to draw a similar triangle. $30 degrees. Call this side 20. And I'm going to add another side. It's going to have a length of 2. Doesn't quite reach the bottom, does it? It's possible that this side just might be too darn short, and therefore you would get no solution. Some people say, well, how do you know it's too short? Well, let's think about the no solution option. Say I got sine of theta is equal to 1.6758. Can sine be equal to that? Why? Yep, the maximum value of sine is 1, and the minimum value is negative 1. This is outside the boundary for what sine can be. So therefore, you would get a no solution situation. You'd be talking about this little thing up here, and it just won't make it. No matter how you turn or flip it around, it just can't find its way down. Now, the question is, could you have it be 200? Or is that just too long? You could. You could have it be 200. It would be stretched way out over here, right? But it would still be able to connect at some time. So it's not an issue of whether it's too long. It's an issue that it could be too short in that scenario. Okay? So here we go. Let's flip it over. Look at this one. Side angle, opposite leg is longer. Okay? This is the other one, and we're getting a one solution scenario. Okay? So suppose I have an angle formed, call it a 30-degree angle. We'll call this 20, and we'll call this 40. Is the side opposite the angle longer or shorter than the other given side? Longer. As you can see, it creates a 90-degree triangle. Right? It creates a triangle. Makes the shape. Okay? Now, watch what happens if I try to rotate this like the pendulum that we did before. You do that, you're no longer going to be able to maintain that 30-degree angle, are you? You get a weird, odd triangle of some sort. So you can see that when the side opposite the angle is longer, it only creates one triangle. Are you ready to think a little bit deeper and chance you might understand this a little bit better? Okay? Here's the whole idea. We're trying to figure out if there's an obtuse angle. That's the whole idea. Because sine is acute in the first, it is obtuse in the second. So think about this. This angle right here, is it possible in any way, shape, or form to be obtuse? Why? How do you know? Suppose I drew it differently. Look at the numbers. There's a numerical answer for this. Don't even have to think about that. You guys are doing great work. Continue. Look at the numbers. Good. So, look at that. If 30 degrees is 40, length per side, that means that 20, this angle must be less than what angle? Less than 30, right? So therefore we know this must be acute. There's no question of whether it could be acute or obtuse. It's going to be acute because of that setup. Whereas in the other scenarios, that was completely different. Look at this one, 30 degrees and 14. Is it possible that this angle right here could be obtuse? Well, yeah, because 20, that means it's going to be greater than 30. So we don't know if that means it's going to be, say, 50 or 150. That's what creates the confusion. Let's see it work out and play out in 3 examples. Example 1, solve the following triangles by classifying which of the 5 cases it will be. I draw my triangle. A, B, C. A is 42 degrees, B is 12, and A is 22. We'll think about this two ways. We'll pick up where we just left off. What angle would I be solving for? B. Is it possible for B to be obtuse? No, because it's got to be less than 42. So, here's how this works out in the decision tree. Which of the 6 scenarios do we have? Side-side angle. So I go down the side-side angle, and I answer this question. Is the side opposite the angle longer than the other given side, or is the side opposite the angle shorter than the other given side? Which one is it? Side opposite the angle is longer than the other given side. See that? So therefore, I follow the decision tree. It says there's just one solution. Use the law of sines. So there's 3 different scenarios you can get here. This one says one solution, so I use it. A, B, C, little a, little b equals C. A is 42, little a is 22, and little b is 12. What am I solving for? Sine of b. So sine of 42 divided by 22 is equal to sine of b divided by, and I cross multiply. Yep, degrees. 12 sine 42 divided by 22. I get 0.3650. Can sine be equal to 0.3560 or 0.3650? Yes, it can be equal to that. So I do have a possible solution. Again, why are we so convinced that it's acute? Yep, and that's what the decision tree takes care for us. So we don't really have to think about. So I can have confidence that when I hit sine inverse of this answer, that the acute angle it comes up with, 21.41, is accurate. So I get for angle B, 21.41 degrees. Now what? Solve for C. So 180 minus 42 minus 21.41 is 116.59. I go second and then ANS. So it's a negative sign. How do I find C? Law of sines, sine of 42 divided by 22 equals sine of 116.59 over C. Cross multiply and solve. .40. Again, the whole issue is trying to force out the possible obtuse angle. Did we find an obtuse angle? Yep. But I want to show you something that third hour did not see. Okay? This is kind of interesting. This is an obtuse angle. I'm going to write an acute angle that's similar to this in certain ways, and I'll show you in a second how I came up with it. But it's going to be 63.41. Okay? Now, watch what happens here. Had you used the law of sine and you were finding C, okay, it won't give you 116. Watch. If I take the sine of 116.59, I get 0.8942. Okay? If I inverse that answer, what would you expect to get? 116.59. But you don't. You get 63.41. Your calculator can only come up with the angle that sits in the first degree, or first quadrant. It doesn't know to get the one from the second quadrant, because sine is positive in both the first and the second. How does it distinguish? And that's why we have to lay out what we have. Now, I know that's in depth, but I'll tell you, that's nothing that was ever explained to me when I was your age, okay? I just kind of had to figure that out as I went. So that's what's happening. Let's look at the difference here. Here we have angle A, angle B, and angle C. And side A is 15, side B is 25, and angle A is 85 degrees. Which of the 6 scenarios is this? Side angle. So I go down to this piece here, and I ask myself, is the side opposite the angle longer, or is the side opposite the angle shorter? It is shorter. Oh no. Now I have one of these two options. It says, when solving for the missing angle, if sine is greater than 0, there's no solution. Or, when solving for the missing angle, if sine of theta is less than 1, then there are 2 solutions. Did I say 0 there? Sorry. If sine is greater than 1, no solution. If sine is less than 1, then there are 2. So I don't know which one I'm going to get. So here's what I'll do. I'll set it up. There it is. Okay. Sine of what? 85 over equals sine of over 25. And so I'm going to multiply the other side by 25. 25 sine of 85. Divide by 15. 1.66. Is that a possible solution? If you go sine inverse of that answer, you got a domain error. It doesn't like trying to take the inverse sine of that. It can't do it because sine's never equal to that. So therefore, this is an easy problem. It is a no solution. It's not possible to have a triangle with these characteristics. And what that means is this 15 side right here, it just doesn't reach. Maybe if it was 21. Don't know. We can figure it out later. Okay, last one. Set it up again. Do I draw my triangles proportionally to how they're supposed to? No, I just draw a triangle. I put 20.5. I don't care if it's a 20.5 degree angle. I just draw it. Which of the 3 or 6 situations do I have? The side angle. Is the side opposite the angle longer than the other side or shorter than the other side? Shorter. It says that I either have no solution or 2 solutions. I don't know until I start to try to solve. So I take sine of 20.5 divided by equals sine of b divided by 31. And I get 0.9047. Is that a possible solution for sine? It is. The problem is we don't know whether it's the first quadrant or the second quadrant. There's no way to determine. Look at you guys. Is angle B going to be greater than 20.5 or smaller than 20.5? greater. So it could be 50 or 150. We don't know. So at this point, set up two possible triangle solutions. That's what I do. Triangle 1, triangle 2. A, B, C, little a, little b, little c. Angle A will be 20.5 degrees for both of them. Side lengths, B will be 31. A will be 12. What changes is when we start solving for angle B. Here's a big mistake people make. They go through this and they just set up triangle 1. Then they have no idea how to set up the second triangle. As soon as you know that there's two triangles, set them both up, because this is the point where it matters. I do the sine inverse of that answer, and I get 64.78. That's the acute angle. It says triangle 1 will have theta be an acute angle. Triangle 2 will have theta be an obtuse angle. To find theta, simply use sine inverse, which we did. To find the obtuse angle, simply take 180 minus theta. So, if our first triangle has b equal to 64.78, then the second triangle will be 180 minus 64.78, or 115.22. You can see that angle B is where we really start to differentiate between the two triangles. Can I now find angle C? Will it be the same for each triangle or different for each triangle? It'll be different. So 180 minus 20.5 minus 64.78. I get 94.72. The other one, 180 minus 115.22 minus 20.5. I get 44.28. Can you then find C? How? Yep, just use the law of sines. Sine of 20.5 over 12 equal to sine of 94.72 divided by C. I get 34.15. And then for this one, sine of 20.5 divided by 12 is equal to the sine of 44.28 divided by C. So again, to save time, I'm just going to choose this option on my calculator to hit second entry, and I can just go back and change the 94.72 to 44.28. It'll give me 23.92. Are my answers reasonable? Yes, because the largest side matches up with the largest angle, and the smallest side matches up with the smallest angle in both triangles. So you've seen a no solution, you've seen a one solution, you've seen a two solution. Part of what I want you to know is that in all these triangles, we started with the angle being an acute angle. I told you the whole trick is to try to force out the obtuse angle. So flip it over, you'll see the obtuse. Suppose I did have an obtuse angle. If it's an obtuse angle, is it possible for either of the other angles to be obtuse? No, you can only have one obtuse angle in a triangle, right? What do you notice about this scenario? This is an impossible triangle because if A was an obtuse angle, you would have to have a side greater than 21, right? Or greater than 20. You can't have the largest angle have a side that's smaller than one of the other sides. So I don't even set it up. If you set it up and solve it, you'll come up with a solution, and it will be incorrect. You'll get it, and that's your indication it'll be correct. I think in some situations they think you actually come up with a negative angle, is what happens. Okay, so that's because here's the problem. When you type 105 into your calculator, you start doing the law of sines, sine of 105 divided by 4. Your calculator thinks that it treats 105 the same as it does 75. Let's change it. If it was 75, is that possible? It might be. Your calculator doesn't know the difference. You could take sine of 105, type in your calculator, you're going to get the same thing as sine of 75. It doesn't know. So you got to be smarter to figure it out. Let's try this one. Suppose I have A equal to 152 degrees. Side A is 11.4 and side B is 8.6. Is that a possible triangle? Yeah. And so you'll just come up with one solution using the law of sines. So when I made the decision tree, I chose to not talk about acute angles and obtuse angles. It simply says, is the angle opposite, or is the side opposite the angle longer or shorter? And so if you got an obtuse angle, then try to think of those two scenarios. I didn't want to put too much on that one sheet, okay? So your assignment today is crucial. It's the hardest assignment that you have. And it's a great way to make sure you're prepared for the test. Because I will not tell you at all on the test which 6 of these scenarios you get. You've got to be able to look. I'll just give you 6 problems, and you got to know whether it's a side, 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 an angle, angle, side, a side, side, angle, a side, angle, side. You got to know whether you come up with one solution, 2 solutions, or no solutions. But you do get to use the decision tree. Fair enough? Okay. Here's your assignment. It's assignment from the book. It's 8 problems. 15 through 22. You're going to get some that are 2 solutions, some that are no solutions, some that are 1 solutions. You got to be able to think it through and figure it out. So you're very smart. You won't have any problem.